Thanks for tuning in. So today I will be looking at a sketch that deals with an output and an input. And I suppose that whatever the input is will determine the output. But first, before I get into that, I wanted to include in this video a refresher as to what the Boolean operator exclamation mark symbol means and does. So I managed in a roundabout way to look this information up on the Arduino website. And it took me to this page, which I hope I can remember to leave a link in the description below for, and it's the language reference page. Arduino programming language can be divided in three main parts: functions, values, variables and constants, and structure. So here's functions, and it shows digital read, digital write, pin mode, and I suppose maybe I could pause it if I want to read all this, but it's almost like a index or an overview of the C language or C++ language. Anyway, there's variables, and here in the structure section it shows a lot of different basic elements or arguments. This is C++ code, and in this list is our Boolean operators. So here's the exclamation mark, which is logical not. So I will open that up. Boolean operators, logical not, results in a true if the operand is false, and vice versa. Example code: this operator can be used inside the condition of an if statement. If exclamation mark X, and then there's a comment, if X is not true, and then I suppose something happens. It can be used to invert the Boolean value. X equals not Y. The inverted value of Y is stored in X. Notes and warnings. The bit wise not tilde looks much different than the Boolean not, exclamation, point, or bang, as the programmers say, but you still have to be sure which one you want where. So now I will read some basic code. There are some integer values as global variables defined at the top of the sketch. Const int in pin, short for input pin, equals 5. Const int led equals 13. So of course these will be assigned to the corresponding pins when pin mode is used. So then here led, which is pin 13 or integer value 13, becomes the output pin when pin mode is used. Likewise, pin mode is declaring in pin equals 5 an input pull-up resistor, an input pull-up pin with a pull-up resistor inside. Okay, so the void loop creates another variable. Would you call this a local variable? Open switch equals digital read of whatever in pin happens to be at the current time. And then according to this new variable that was declared, which depends upon in pin, it will digital write the LED pin, which is pin 13, according to what this new variable open switch is determined to be. And well, this is really what I should have done. I should have zoomed in on the code. so it could be visibly seen. But anyway, when the in pin is sent a low, which is a ground, signal a 0, then LED pin will be high. So it's kind of the opposite. And when a high is sent to the in pin, which actually is automatic because in pin has the pull-up resistor on it, then digital write LED pin 13 will be sent low. In its resting state, pin 13 is low or off. The LED is off, and that's because of the internal pull-up resistor on the in pin. Well, now I'm just becoming redundant and repeating myself.
Alright, so here is the sketch hooked up. Pin 13, the orange one here, is the output pin, and it is being hooked up to a current limiting resistor, which is 10K, through the positive side of the LED and back to ground. And I suppose the way this sketch is supposed to work is that when pin 5 is sent to ground, then it sends pin 13 high.
Thank you for watching.